Hello, welcome back, Introstat student. Um, as you can tell, I'm having a little bit of a blocked nose, but hope that doesn't interfere with the video today. So today we will do, for this video, I'm going to try to do the exercise on finding probabilities with sample means. The last video we talked about sample means and the central limit theorem. So what it's saying is central limit theorem says that if you have a large enough sample size, and preferably more than 30, right? Preferably more than 30. Is that a magic number? No, but it's that's what statisticians have agreed that the as long as the sample size is greater than 30, the sampling distribution of the sample mean is going to be approximately normal. So have as big a sample size as possible when you're dealing with means. Um, and central limit theorem would be applied, and therefore the sampling distribution of sample mean will be approximately normal. So let's go to finding probabilities with sample mean. Okay, so first question. A scientist studying water qualities measures the lead level in parts per billion ppb at each of 49 randomly chosen locations along a water line. I like the number 49. All right, here 49, which is a good number because the n is 49, which is greater or equals to 10, which means central limit theorem is applied, which tells us that the sampling distribution of the sample mean is approximately normal. Suppose that the lead levels across all the locations on this line are strongly skewed to the right, and the mean, right, is 17, and the standard deviation is 14. Assume that the measurements in the sample are independent. What is the probability that the mean lead level from the sample of 49 measurements x bar is less than 15 parts per billion? So we have to, first of all, understand. Okay, so we have the your sampling distribution. Okay, we have the sampling distribution, and the mean here, right? The mean here will be equivalent to the mean of the population. In this case, the mean of population is 17. Okay, so here the mean is 17. So they want us to find the probability so that the sample mean is less than 15. So less than 15 is about here. So let's say this is 15. Less than 15 is shaded to the left, right? So this is towards negative infinity. So I have all the information. I have my lower bound, which is negative infinity, upper bound, which is 15, and I have my mean, and I need to find this. I need to find the standard deviation, right, of the sampling distribution of the sample mean. And that is standard deviation of the population standard deviation divided by root n. Okay? So, and in this case, divided by root n is standard deviation is 14 divided by root 49. And root 49 is 7. So 14 divided by 7 is 2. So the standard deviation is 2. So we now know that the sampling distribution is approximately normal. And to find probability, we need this normal CDF, right? We need normal CDF. And we need 4 things. So here we need the lower bound. The lower bound is negative 99999, and the upper bound, which is right here, 15. That's the endpoint of the shaded area. The mean happens to be 17, right? Mean of the population, right? because they are unbiased estimator. So the mean of the sampling distribution of the sample mean should be the same as the population mean, 17. Standard deviation we just found is 2. Standard deviation of the sampling distribution is 2. So if you put this in your calculator, I need to write that down. Okay, so if you go to the calculator, if you go to second bars, now we need to go to normal CDF. And okay, so the lower bound is negative 999, and upper bound should be 15. The mean should be 17. Standard deviation is 2. So it's about 0.1. We're supposed to round this to the nearest 2 decimal place, so it's 0.16. So let's see if we have any answer that's there's one right here, 0.16. Okay, so another question. A car manufacturer crash tests a certain model of car and measures the impact force. The test and model in question produce impact forces that are normally distributed with a mean of 30 metric tons and a standard deviation of 1.5. So our population has been, the population is normally distributed, right, with a mean of 30 and standard deviation of 1.5. Suppose that the manufacturer tests a random sample of 4. Now 4, which is less than 30. But the fact is that the population is normally distributed. The sampling distribution of the sample mean will also be normal. Okay? So even though the n here is small, the n here is really small, it's 4, it's not more than 30, we still know that the sampling distribution of the sample mean is going to be approximately normal. Now, what is the mean of the sampling distribution? It should be the mean of the population. In this case, the mean of the population is 30. And what is the standard deviation? It's the standard deviation of the population divided by root n. So, mean standard deviation 1.5 divided by root 4. Now, root 4 is 2, isn't it? 1.5 divided by 2 is 7 point, 7 point, 1.5, 7.25. Nope, 1.5 divided by 2 is 0.75. Okay. .75, right? 0.75. So we need to go to normal CDF, right? Normal CDF, and we need 4 things. So here we are asking, what's the probability that the mean impact force from a sample of 4 cars of X bar exceeds 30.75? Now we know that the sampling distribution, the shape is approximately normal. And here the middle, right, the mean is 30, right? Because it's unbiased estimator. And 30.75, let's say 30.75 is here, 30.75. And we want to find the probability that it exceeds that. So it's going to be this direction towards positive infinity. So what is the lower bound? The lower bound should be at this point, 30.75. Upper bound, it's going to the right, which is positive infinity, right? And then the mean is 30. Standard deviation is 0.75, right? This is mean of the sampling distribution of sample mean. This is the standard deviation of the sampling distribution of the sample mean. So, to keep all those data before I show you on the calculator. So, if you go to the calculator, right, how do we get to normal CDF? Second bars, right? Number 2, normal CDF. And it is going from 30.75 to the upper bound is 99999, and then the mean is 30, right? Mean of the sampling distribution is 30, and the standard deviation is 0.75, and round off to the nearest two decimal place is 0.16. So any of the answer here, 0.16 right here. So hopefully this help explains the exercise, and if you have any questions, do let me know. Thank you very much. Bye bye.